Bren, sod sa beat.
We have P, Q, and R here. We have to identify first and evaluate its validity. There are formulas that we're going to solve. First, P conditional to Q and P. So if a television won't turn on without electricity, then the television don't have electricity. A television will not turn on without electricity. Therefore, the television don't have electricity. To prove that this statement is valid or invalid, using this truth table, which we have P, Q, and P conditional to Q. To prove that is valid or invalid, P and Q there is already given. Column P, true, 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 true. False, 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 and false. Column Q, true, true, false, false, true, true, false, and false. True and true. To get the column of P conditional to Q, you just have to compare P and Q column. So first, T and T is equal to T. Second, T and T is equal to T. Third, T and 0 is equal to 0. Fourth, T and 0 is equal to 0. Fifth, 0 and true is equal to 0. 0 and true is equal to 0. 0 and 0 is equal to T. 0 and 0 is equal to T. Therefore, negation of P and Q and P over therefore Q is valid. The next formula that we're going to tackle is P conditional to Q and negation of Q over therefore negation of P. If a television won't turn on without electricity, then the television don't have electricity. Then the television do not have electricity. Therefore, the television will not turn on without electricity. To prove that this is valid or invalid, through this truth table, we have to identify first the P, Q, negation of P, negation of Q, and P conditional to Q. Since the P and Q columns are already given, starting to the negation of P, first, 1 and 1 is false. Second, 1 and 1 is false. Third, 1 and 0 is 0. Fourth, 1 and 0 is 0. Fifth, 0 and 1 is 1. Sixth, 0 and 1 is 1. Seventh, 0 and 0 is 1. Eighth, 0 and 0 is 1. Therefore, the example number 2 is valid. This is our circuit example. The circuit have two types, the series and the parallel one. So our circuit is at parallel type. To get this formula, first step is negation of P and Q. You write it down over there, close and open parenthesis. Or P and negation of Q. You also have to write it down here, then R. So this is our formula now. To write it on a truth table, you have to write the variables accordingly or in order. So here, based on our formula, we have to put each of the variables on the top of the table. to start with, P, Q, and R is already given. In the column of P, 1, 1, 1, 1, 0, 0, 0, 0. And the Q, 1, 1, 0, 0, 1, 1, 0, 0. And in the column of R is 1, 0, 1, 0, 1, 0, 1, and 0. Negation of P, we have to find it here. So, 1 is to 0, and 1, 0, 1, 0, 1, 0, 0 is 1, 0, 1, 0, 1, and 0, 1. So to get the column of negation of P, we have to base it over here in the P. So 1, 0, 1, 0, 1, 0, 1, 0, and 0, 1, 0, 1, 0, 1, 0, 1. Next, the negation of Q here. We have to base it also in here, the column of Q. So 1 is 0, 1, 0, 0, 1, 0, 1, 1. 0, 1, 0, 0, 1, 0, 1. To be followed by negation of P and Q. The negation of P here and Q here. So, negation of P, 0, 1 is 0. 0, 1 is 0. 0 and 0 is 0. 0 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. 1 and 0 is 0. 1 and 0 is 0. To get the P and negation of Q, we have to base it on their columns, which is P and negation of Q. So P and Q is 1 and 0 is 0. 1 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. 0 is 0 and 0 is 0. 0 and 0 is 0. 0 and 1 is 0. 0 and 1 is 0. So to get this negation of P and Q, or P and negation of Q, to base it on this two columns, which is this one. 0 or 0 is 0. 0 or 0 is 0. 0 or 1 is 1. 0 or 1 is 1. 1 or 0 is 1. 1 or 0 is 1. 0 or 0 is 0. 0 or 0 is 0. Whole formula. So to get this is we have to base it in this column and also this column R. So 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. Now, our output here, this one, we only have two cases wherein the output is on. This one, and this one. Therefore, there are only two cases where the output is on. That is when P is on, Q is off, R is on. And P is off, Q is on, R is on, while the rest of the cases are off. For our first diagram, we have an argument of all apples are red. From the word all apples are red, we have a diagram of all apples here and a red. So all apple. That is our diagram here. For our next problem is no dogs are red. Apple is not a cow. Apple is red. Diagram here is no. From the word no. So no dogs and cows. Dogs and cows. And apple. Red. So no dogs are red. Apple is not a cow. Apple is red. So we're going to put no here. Some example. Some apples are red. So from the word some. So the Euler diagram here is the apple. And red. So from the word some, we're going to put the dot here. Because it is said that some apples are red. Red. So not all red, not all apples are red, but some red are apples. So we're going to put that here. Some apples are not red. So the Euler diagram here is some apples and red. So we're going to identify that some apples are not red. So some apples are not red.
So, hey guys, thank you for watching my video and hoping that you learned something from evaluating an argument using truth table and also Euler diagram. Thanks for watching.